Okay. I did receive some comments on the homework submission, guys. I'm sorry. I think some of you were not able to submit homework, right? I'm sorry about it, but I did clear it out. You should be able to submit your homework now. I think so. And on the homework, did you have any questions? On the homework, did you have any questions?
I had a question on the proofs. I have a question on the proofs.
Okay, I'll go there.
Also, I wasn't able to finish the homework. It
Yeah,
was
I
a bit
wasn't
too.
able to finish everything.
Okay, wait, I'll come. One second, guys. Your classroom. Okay, proof you all had problems with. Manya, can you educate me on? Chetan is not here, right? One second, guys. One second, please. Manya, what are they doing in school, ma?
So we just started like image and pre-image and like reflections over like the X and Y axis and how to graph all those.
That is our plan for today too. How about Dia?
Yeah, we were doing the transformations like the translation, rotation.
I see. I see. Give me a minute. Okay, let's see. Okay, how about this? Let me go to your homework. Let me share that homework. Let's see where are the questions and then we'll move on to transformations. Mm, start recording. Okay, yeah.
Can you go over number 23?
Absolutely. Okay. Anybody wants to help me? Anybody would like to help me?
First would be given.
Yep, given. Yep, that's right. That's there. Given. Okay. So basically, L is parallel to M they've given. We have to prove that A is parallel to B. Okay. So L is parallel to M given. So what? And then what?
1 and 3 are corresponding.
1 and 3 you want. Okay. 1 and 3. 1. Okay. 1 and 3 are corresponding angles. Correct. Okay. Considering A as a transversal, 1 and 3 are corresponding angles. So 1 is congruent to 3 corresponding angle postulate. Corresponding angles postulate. Then next one. Manya, you.
1 and 7 are corresponding and it's given.
1
Should
is
we do
congruent to 7 is
I
given.
mean congruent, sorry.
Then Aditi, are you here, Aditi? We are working on proofs.
Yeah, I'm.
Okay. Okay. Now what happens? The next one. See this sequence. What happens next?
Angle 3 is congruent to 7.
Good job. Angle 3 is congruent to angle 7. What is the reasoning?
Is it substitution?
Yeah, substitution, because see, angle 1 is congruent to angle 2. Angle 1 is congruent to angle 3. The same angle is congruent to two different, so this is substitution.
I have a question.
Go ahead.
What's the difference between substitution and transitive?
That's exactly what I explained now. Angle 1, last week the same thing was discussed when Dia asked in class. 1 is congruent to 2, 1 is congruent to 3. If you have scenario like this, the same angle being equal to different angles. Here, angle 1,
No, I'm just saying, I'm asking if substitution and transitive mean the same thing.
no, that's what I'm explaining. So here, but a good question, Akash. 1 is congruent to 2, 2 is congruent to angle 3. This is transition. See, 1 transitions to 2, 2 transitions to 3. Here, 1 is equal to 2, 1 is equal to 3. Does it make sense?
Yeah.
So
Wait,
here,
2 and 3, they don't seem like equal though.
It's an example.
2 and, oh yeah. Prisha, this one I just said as an example.
Okay.
This is not, I'm glad you asked me. This is not related to the figure at all. I just wanted to differentiate transition property and substitution property. So I just gave you 1, 2, 3 as angles. Okay, now let me go ahead and erase this. So here you see, Akash, 1 is equal to 3, 1 is equal to 7. So that becomes substitution. So now
Yeah.
we see 3 is congruent to 7. Now what is the last? Anybody? Manya, you want to conclude the theorem, conclude the proof?
A is congruent to B.
A,
Oh, sorry, parallel.
Okay, why?
Because it's corresponding.
Yeah, but the reasoning?
Definition of parallel lines.
Is it?
No.
I don't know the theorem name, but is it if corresponding angles are equal, then the lines are parallel?
Very nice. What is that? Exactly.
The
What-
converse.
Huh?
The converse of corresponding angles.
Wow, correct. Convert. Okay, let me one more time clarify, guys. Okay, so here when these two are parallel lines, there's a transversal. Okay, when they give you L is parallel to M, you can say 1 is congruent to 2. Why? This is the corresponding angle postulate. They've given that they are parallel. Your concluding angles are congruent. Then it's the postulate. But the other way, right? Hypothesis, this is conclusion. When they switch, what happens? What do we say? Converse of correspond, when 1 is equal to 2 and you're proving that L is parallel to M, you say converse of corresponding angle postulate. Any questions?
Wait, is the corresponding angle postulate corresponding angles are equal?
Yeah, meaning corresponding angle postulate says when there are two parallel lines, the corresponding angles are equal.
So it's the yeah, I get it.
Makes sense. Okay. Can I move on? Any other questions?
Could you go over number 17?
Yeah, we will go over proofs as many as you want, Ma, because they are quite
Wait,
important.
can we go over 23?
23, 17 and 23 I'll go over. Okay, now 17, Amma, sorry. Okay, what is that? What is that? 17, 17 was what was asked, right?
Yeah.
Okay, definitely yes. So 1 is equal to 16. What is that 1 is equal to 16? Oh my goodness. Okay. Wait, guys, I need to read what is this question. Use the figure and the given information to determine which lines are parallel. Justify using a theorem or a postulate. So 1 is equal to 16. Okay. Why would 1 be equal to 16? What did you guys get? 1 is congruent to 16?
Shouldn't it be none?
That's what I feel. Just use the given figure and given information to determine which lines, if any, are parallel. Justify using a theorem or postulate. But looks like it is already there, right? Meaning, is there any none? Answer. For me, it looks like it's none because 1 is not, equal to 16 just because two lines are parallel. We require more inputs, I feel. Did I give you the answer key for this one? Did I give you the answer key as well for that one?
Yeah, I think so.
Okay. So 1 is equal to 6. Yeah, see, 1 is 16. Yes, it's none. Manav, did you check the answer key on that?
No, I did too, but I forgot to check it.
It's important, okay? I'm saying you don't do two problems. You spend that time checking. You see what I mean, Manav? That's so important to check answers, what we do. You should know what you got right and what you didn't get it right, okay? It's for your benefit, not now. Even if you go to college, right? Do 10 problems, check whether they are right. That is so important rather than doing two more and not checking, okay? Just a thought, okay? So now
Okay.
for 17, right? Or 17 was asked, right? 1 is 6 cannot be proven at all. There is no relation. So this cannot be concluded. 1 is congruent to 16. It's not a conclusion that can be made.
Wait, Auntie, I don't know if this is right, but could you say that they're vertical angles? Like vertical
Good question.
lines?
Prisha, nice. Yeah. See, because they form an X, the X means here, they need to touch it. This intersection point should be there. Then only I can say they are. Does it make sense, ma? Then only I can say that they are vertical angles. Vertical angle theorem comes into picture only when there is an intersection. Here, do you see the intersections here? Prisha, to answer your question directly, I can say 1 is equal to 6. 1 is congruent to 6. I can say 2 is congruent to 5. There is an intersection point. They are the vertical angles. You got it?
Oh, okay. Yeah, that makes sense.
Anything else? 23. Somebody, Manav asked 23, right? Can I go over 23? I want somebody to help, please, with the reasoning. Aditi, this time, can I get your help?
For 23?
Yeah.
Okay.
Yeah, absolutely okay if you don't get it. Okay, doesn't matter at all. I can switch to somebody else. How about this? 5 supplementary to 2. What is the reasoning?
5 supplementary to 2?
Yeah, 5 supplementary to 2.
For 23?
For 23. What is the reasoning?
I can't see your screen. It's like still at
You're showing us
7.
like 14, 15, 16, 17.
Yeah, it's still at that area.
Thank you. How about this? Are you able to see now?
Oh, that'd be given. 5 supplementary to 2.
Yeah, 5 supplementary to 2.
That's given.
Given, good job. And then, what is the next one I can conclude? Wait, let me also see. I have to have a.
Wait, if it's supplementary, wouldn't like measure 5 plus measure 2 be 180?
Correct.
So
Measure
then that'd be like
2 is equal to
depth of supplementary
definition. That's the definition.
definition of, yeah, supplementary angles.
Supplementary.
And then A parallel to B would be also given.
A parallel to, yeah, correct, given. Then 1 minute, 5 and 2 are supplementary we did, right? Okay.
Yeah,
And
those are
then
supplementary.
A
And then,
parallel.
so 1 and 5 are corresponding. So wouldn't it be like that, what you said earlier, the corresponding angle postulate? Like,
Okay, 1 is congruent to 5.
yeah, they're corresponding.
Yeah, corresponding angle postulate. Good job. And then the next one?
So to connect them, I would do like 1 and 2 are 180 degrees. Like,
1 minute, 1 minute. Here I want to take a break. 1 and 5 are corresponding angle postulate. Okay. But the next one is what? Something about 1 and 2, right? What do you want to say?
oh, if they're 180 degrees, then you could also say that like measure 1 plus measure 2 is 180, right?
Measure 1 plus measure 2
You would
is
say
1.
you would say
Oh,
1 plus 2 is supplementary. Because the next one is measure 1 plus 2 is.
like you could say some
That's what
supplementary 180
see,
degrees.
then this line says measure 1 and measure 2 is equal to 180 degree, which is the definition of
Oh, wait, I didn't see that. Oh, okay, so that would be,
so in
yeah,
that case,
1 and 2 are supplementary, yeah.
that's what I feel. 1 and 2 should be supplementary.
Oh yeah, I didn't see that. That's
No problem. 1 and 2 are supplementary
And
means,
that's like definition of supplementary angles again.
yeah,
right?
but wait. But 1 and 2, see, this is definition of supplementary angles.
Oh yeah.
Yeah, but then the previous reasoning doesn't seem right.
Okay, then
1 and 2 are why supplementary?
Because they equal 180, so wouldn't it be substitution?
Let's see. Let's see. We have said 5 is supplementary to 2. And then here we have said 1 is supplementary to 2. Okay, wait. Equals. See, only when they are equal, you can use substitution or transitive property. For supplementary, you cannot use. You see what I mean?
Oh, okay.
So there is a separate theorem. I am very positive we discussed this in a separate class. Complement of complements theorem and supplement of supplements theorem.
Oh, I don't remember that.
Okay, I will go over it again because those two really you can all forget very easily. Supplement of supplements theorem and complement of complements theorem, because I remember every year I forget it. So this year I made sure I covered it in one of the classes. Supplement of supplements theorem and complements of complements theorem. Complement of complements theorem. These two are separate theorems which you should know definitely. So when you think about, let's say, angle A, angle B. Okay. Now, do you see it here? Angle A plus B, measure of angle A plus measure of angle B is 180. Measure of angle B plus measure of angle C is 180. You see? So what I can say about A, B are supplementary, B, C are supplementary. So what do you think about, see, B is common to both, right? A and C are supplementary. So supplement of supplements, you see, supplement of supplements is supplementary as well. You see what I mean? Meaning, if A plus B is 180, B plus C is 180, then this is the supplement of B, right? This is the supplement of B again. A is the supplement of B. C is the supplement of B. Now, you see, these two are supplements of the same supplement, right? So, supplement of supplements are as well supplementary. So, A plus C is supplementary too. So, it is the supplement of supplements theorem. Or I'll protect it as supplement theorem. And then what? What next?
I have a question.
Yeah, go ahead. Good, Akash.
So only if 1 and 5 were supplementary, then only you could say 1 and 2 are supplementary, right?
Yeah, suppose if
Then
two,
only you could have write substitution, right? If 1 and 5, if it said 1 and 5 were supplementary, then only you could say 1 the
illa,
substitution.
correct, Akash. No. Only when they are equal, you can talk about that, Akash. You see what I mean, huh? Meaning, mm,
No, only when the two statements are like the same.
No. I think I didn't make help you understand. What I'm saying is, substitution and transition. I'll tell you here. Substitution and transition comes only when there is an equal to sign, I'm saying. This is transitive property of equality. Transition property applies to equations, property of equality. 1 is equal to 2, 1 is equal to 3. This is substitution property of equality. Because we don't write it, you're not knowing. Equality. Okay. Only when they are equations, you can use this, I'm saying. Okay, now 1 and 5 are supplementary is different, right? There is you're adding and saying, and then you're saying 2 and 5 are supplementary means you can conclude that 1 and 2 are supplementary, and the reason is always supplement of supplements theorem. Am I making sense?
Yeah.
So here, none of this comes. Transitive or substitution property do not come because they are not directly equal. We are not making two angles equal. We are making some of the angles equal, some of the angles equal. This is entirely different from this one. Akash, am I making sense?
Yeah.
Great question.
Miss
Yes,
Priya?
Manya, what is that, ma?
I just had a question about the supplement theorem. Would you have to write supplement of supplements theorem, or is just supplement
It
theorem?
is not supplement theorem, ma. Supplement of supplements. Full you need to write. Got it?
Okay, yeah. And is there no like abbreviation?
Supplements of supplement. What, ma?
Is there no like abbreviation or anything?
1 minute, I can check. You asked me a good question. Let's. I did post a list of theorems in the Google Classroom. I don't know whether you guys saw. Did you guys see?
Yeah.
Congruent supplements theorem. I really want it to be nice. Wait. Let's see if this is what we want to. No, we don't want. 1 second, guys. Let me go to the Google Classroom itself. There it's very much clearer. There's a list of theorems and postulates which we have. I'm sorry, guys. In the classroom, there's a list of theorems that we discussed, and I really want to point it out. This is where you can see hereafter. So like that, I want to point it out for you. Hold on. But where is the rest? Oh, did I change the classroom? What is going on, guys? Oh, did I change the summer classroom? Yes, I did. That's the problem. So you guys don't have it, some of you. Did I post it or not? Somebody give me input, guys. Did I post it or not?
I remember you telling us about it. I can check in the summer one or in the other one too.
Yeah, even I remember telling, but telling is not equal to putting, right? I should have put it in the Google Classroom, I feel. 1 second, guys. You really need it, actually. See, this is what you really need, all these. So I will go ahead and put it supplement of supplement and congruent complements theorem. Okay, congruent complements theorem, supplement, let's see, that is, if two angles are complementary to the same angle, then they're congruent. That theorem, does it apply here? Hold on, let me quickly check, guys. Then supplement, congruent complements theorem is. Let me quickly go over that, guys. This theorem may not apply there. Hold on, supplement, where is that supplements theorem? See, this is the big list of theorem that we can use to understand, but where is the supplement? Let's see. Hold on. I feel like this theorem does not apply there, guys. Give a minute. Congruent complements. See, if two angles are supplementary to the same angle, then they're congruent is what you can conclude. That's not making sense to me. So let me share this in Google Classroom, but this is not making sense, right? Let me put it out here. Let me put it out here and then we'll go back to our proof. I feel like this theorem is not applicable for that. Let me see.
Miss Priya?
Yeah, ma?
Yeah, you put like slideshows in the summer class with the more like basic postulates.
Oh, but we don't have this big list, right?
No.
Anyway, this is good for you all. Okay, and I feel congruent complements and supplement, this is not applicable. 1 minute, let me go back to our proof. Where was our proof? Okay. Sorry, guys, give a minute. This was 23, right? So we were here, right? Okay, let me come back to the reasoning on that. I feel like this is not applicable. Okay, let me come back to that. And then next, what next? I feel like more of substitution holds good here. See, this plus this equal to 180. This plus, okay, let me go over that. Akash, you brought up a good point as well. I feel like this is not, because see, the statement 6 says 1 plus 2 is equal to 180. So really you're substituting. Let me come back to that reasoning. Okay. I feel like we are incorrect and I was incorrect in the reasoning. So let's move on. 1 plus 2 equal to 180. Aditi, go ahead, Aditi. Definition of supplementary angles. And after that?
maybe like you can do either 1 is congruent to 3 or 1 is congruent to 4.
1 is congruent to 4. Okay, 1 plus 2, you put 180 degrees. 1 and 2 are, 1 and 2 are 180 degrees. So what happened?
So then 1 and 4 can be congruent or 1 and 3 can be congruent. And if 1 and 3 are congruent, it would be like, it'd be
Why, ma?
alternative.
Why 1 and 3 are congruent?
Huh?
Why 1 and 3 are congruent? I don't see a reasoning
Because
there.
they're corresponding.
No, right? That's what we need to prove, right? L is parallel to M.
I don't think you need another one. You just straight go to Alice
Yeah, you
parallel.
could just go straight to L is parallel to M.
I like that.
Or you could say that like 1 is congruent to 4 and say that it's like alternative interior.
You can't, Amma. You can't, Aditi, because see, 1 is congruent to 4. You can't say because you have to prove that L is parallel to M. Who said that 1 is congruent to 4? Did you get from any of these? No, right? We are not even talking about 4 angle. See, only when they had given you L is parallel to M, you can say 1 is congruent to 4. Am I making sense, Aditi?
Oh yeah.
Yeah,
Could you
so
say angle 1 is supplementary to angle 2, and then that would be the definition of supplementary angles? Or never mind, because that was before.
that isn't, see, it's okay. See, proofs, that's what I'm saying. Even here, I felt like I went wrong. It definitely is whatever Akash said. Substitution makes more sense than the supplement of supplements theorem. Okay, supplement of, see, that doesn't make sense because they're congruent, meaning 5 and 2 are 180, 1 and 2 are 180 means I can say that 5 and 1 are congruent. It is not given here. For that, I can say this theorem as reasoning. So this reasoning seems incorrect here. Okay. Let me rewrite it for you. This is corresponding angle postulate, right? Angle postulate. Let's move on. I did not write the reasoning here. Okay, now directly we can go here. But if we go directly, Dia, what is the reasoning?
Would it be the converse of the same side interior?
Nice. So here we have the proof that 1 and 2 are supplementary. So converse of consecutive interior angle theorem. Consecutive or same side interior angle theorem. Okay, here I'll go with substitution because you just substitute this angle 5 plus 2 equal to 180. 1 plus 2 equal to 180. So you just substitute one for the other, right? So I'll go ahead with substitution. Akash, nice catch, Akash. Any other questions? Okay, and the theorem and postulate list I've posted. Any other, Manav, you were the one who asked this, right? You know what? For this one, I would like to go ahead and check the key as well. I want to see why they gave the line number 7. How did they go about it? If I were you, I would have worked the homework like that. 1 and 2, measure of 1 and 2 are 180 degree substitution. Corresponding lines. Okay, that is correct. Oh, they added this. We didn't add that. Measure of angle 1 is equal to measure of angle 5. We did not add that. See, that's why. It's okay, guys. This is really okay. See, definition of corresponding angles we didn't do. That was why we had one more line, which is still okay for us. Can I move on? Manav, can I move on?
Yeah, I got it.
Any other questions you have in this proof? Aditi, do you want to do any other proofs in class?
I don't know.
You don't know. If you want to do, no. From the homework, if you had not understood anything, I would be happy to go over that. Okay, let me move on. Give me a minute. I want to go to transformation properly. I need to check which unit was the transformation. I think it was 8. No, that's similarity. 4 maybe. 4 is transformation. Good. Okay, guys. Okay, I really want to go over these. Now, have you heard of the term vector, guys? Have you heard of the term vector?
Yeah.
How many of you have heard of the term? Hey, Akshita, how are you, Akshita? Are you following?
Following with the postulates.
Oh, okay, good. Okay. Was the homework okay for you?
The homework was okay, but then I didn't have the opportunity to finish the whole homework. So like I finished half of the homework.
Because of too much work at school?
Yeah, it's kind of extreme like this week. We had like a lot of tests.
I see. It's okay, ma'am. Okay. Okay, fine. We'll move on. Have you heard of the term vector, guys? Have you heard of the term vector?
I've heard of the term, but I don't know like everything about it.
Same. I've heard of it. I just don't know what it is.
No problem. Okay.
Like this area, like between both like the lines, this
Yeah.
area is vector.
If I have some arrow pointing in some direction, right? It's a vector. Here, let's say I point this ray as AB. Okay. So this ray AB, right, basically is pointing in a direction, right? Vector has some magnitude. Magnitude means the length of it. Magnitude is the number associated with it plus a direction. Scalar is a quantity that only has magnitude. It does not have direction. Let's see this one.
Yeah, Auntie, so is magnitude like the length of the ray?
Yes. Let's say this is 3. This is 4. This is 5. Do you see here? In this scenario, AB is a vector. You see, vector has the distance 5, which is the magnitude, and a direction. It is pointing to what I can say, northeast. Do you see? It has a direction associated with it. Now, how do you write the vector AB? Vector AB is written as x comma y. 3 comma 4. You see, this point will be 3 comma 4. Does it make sense? You know how to find the magnitude? Apply Pythagorean theorem. You don't need to go that far, guys, okay? You will all learn it again in pre-calculus. So vector has some magnitude and direction. Vector is always associated with a number, the distance, the length of that, whatever the length of that array, and the direction, whereas scalar has only magnitude. How about this? Speed. Have you heard of the term velocity? It has become a physics class now. Have you heard of the term speed and velocity?
A lot of times.
Yeah.
A lot of times, right? So speed is distance by time. When you think about velocity, it is also distance by time. But then velocity has to have a direction associated with it. So velocity will become a vector, speed will become a scalar. This is in physics, okay? I just gave you an example. Your physics teacher will help you understand further, okay? But to differentiate between vector and scalar, if you talk about some quantity that has a direction associated with it, then it becomes a vector. If you talk about some quantity that does not have any direction associated with it, then it becomes a scalar.
So would a scalar just be like a line, for example? Or a
Scalar
line segment?
what speed is a scalar quantity.
No, like, you know how like rays are vectors? Like, what would be classified as a scalar? Like a line?
I didn't get your question. Somewhere we are missing. I'm missing you. What is that?
You said that a ray is like classified as like a vector, like velocity is. So like if a ray is classified as vector, would like a line segment be classified as a scalar?
Lines. No, meaning, see, a ray is a symbol that's used to denote a vector. That's all you see. Meaning, it's just a
Okay.
symbol that can tell you. It doesn't mean that the ray is a vector. What is a vector? Velocity, I said, right? Velocity is a vector.
Then how would he draw a scalar?
We can't, right? It's only a number. You see what I
A
mean?
line can never be a scalar line.
Yeah, you cannot have a line because it's just a
So like a scalar is just like 45 miles per hour or something.
a scalar is a scalar is just 45 miles per hour. Speed is a scalar.
It
Correct.
can be any unit like mass, anything.
Correct. It can be, yes, it can be mass. What other quantities? The temperature at your room, of your room, it's just Fahrenheit or Kelvin or
It's a scalar.
yeah, temperature is a scalar because it's only a number associated, right? Does it make sense?
Yeah.
Yeah.
Okay, how about gravity? How about that? It always acts down, right? It should have associated with it.
Is that a vector?
Yes. You see what I mean? When there is a direction that has to be associated with the quantity that you're talking about, then it becomes a vector. Okay. When it can be only described as a number, you don't need to. Meaning that becomes a scalar quantity. Got it? Okay. But you know what? This is not that much required for our current current transformations. But I thought, okay, I will bring that up. That's it. It will be useful for pre-calc anyway. Okay. Can I move on? Okay, now let's say I have a point here. The transformation comes exactly from your 7th grade. Okay, from the 7th grade, whatever we learned, that is going to come again. 3, 1. You're going to transform this point. Okay, you're going to translate the point. Translate 3 units or 4 units left. 1 unit up. What happens? You know how the translation is written? I'll write the translation, meaning if I want to ask you a question, hey, perform this translation. Perform this translation on this point. How do you perform this translation on this point? Translation means moving up, down, left, right. That is what is translation. Manya, remember we learned it together in 7th?
Yeah.
Yeah, I very much remember this particular topic. 4 units left, 1 unit up. It goes 4 units left. So there's a -1. And then it goes 1 unit up. See, x-axis moves to the left 3 units, up by 1 unit. So what is the point here? What will be the point?
-1, (1).
-1, 2, because it went
Oh,
up,
2,
right?
my bad, my bad.
No problem. So here, what did I do? Basically, you were given the point 3, 1, correct? And then, oh, I asked you 4 units, ma. Sorry, ma. 4 units left, right? So 3 minus, see here, how do you do this? 3 minus 4 is a -1, and then 1 plus 1 is a 2. Do you guys get it? This is how you perform translation. Now, this 3, 1 point, right? The original point that was given, that's called the pre-image. After the transformation, what do you call is the image? Any questions? So translation is pretty easy. See, again and again, whatever we did earlier is going to come. Okay, but then you need to remember. Let's see this one. How do you write the rule of the transformation? I told you, right? Did I tell you? Yes, I think so. The rule of the transformation, you can write it like this. See, the rule of the transformation here was x minus 4, y plus 1. That's the rule for this transformation. 3, 1 becoming -1, 2. What was the rule of the transformation? 3 became -1, right? It was subtracted 4. And then here what happened? 1 became 2 plus 1. So y plus 1, x minus 4. Can I go ahead and give you one more? Sometimes
Yeah, Auntie, for like translations, do you have to use like that bracket to show the translation?
meaning what other ways, ma? I don't see any other way, right? Meaning, is there any other way that you're meaning, referring, and then asking me, or what?
No, I mean like like the triangle kind of thing that you put. Do you have to use that to show a translation, or can you just use like the parentheses?
The parenthesis. You can definitely use a parenthesis. That's why I changed it.
Okay.
Okay, can I move on? Now let's see this one. Can you can you send me the rule for this transformation? See, always guys, remember by convention, meaning by mathematical convention, ABC is always original when there is a dash. I call this as, see, sometimes they call this as A complement. Some people call it as A dash. I call it as A dash. Okay, your teacher may call it as A prime or A complement. Okay, meaning this symbol I'm saying. Sometimes they call it as A complement, A prime or A dash. Now, can you tell me the rule for this transformation? The transformation is translation. I've given you that. Transformation can be, I'll also tell you this guys before we move on. Transformation can be translation. I want you to differentiate this. Translation means move left, right, up, down. Okay. And then it can be reflection or it can be rotation. Okay. Here, the last one is there. That is dilation. There is a big difference between these three and this one. What is it? Who can tell me?
Dilation is exponential.
Yes, dilation is exponential. Okay, agreed. But what is the major difference between
Dilation is the only one that changes the size.
It's
Nice.
vision.
The size? Dilation is the only one that changes the size, meaning the entire picture itself becomes larger or smaller. Whereas in translation, it maintains shape, meaning the image and the pre-image are congruent. You get congruent shapes. Here, you get similar shapes, same shape, but then different sizes. So translation, reflection, rotation maintain the shape. Pre-image and the image are congruent. So these three are called rigid motion. Okay, whereas dilation doesn't. Dilation does not maintain the shape. As a result, dilation is not a rigid motion transformation. Rigid motion means it has to maintain the shape and size. The shape is only maintained, the size is going to change in dilation. But remember one thing I really want you all to know, the angles are also maintained because the shape is congruent here. Here, please remember angles are exactly the same, but the lengths become proportional. Lengths either increase or decrease. Please remember that in dilation. Okay. You know what is isometry? What is isometry? Iso means what? Metry means what? It's just the name, guys. What is isometry? What is isometry?
Is it like geometry?
Metry means measure, ma. Iso means same. Iso means same, right? Isobar, isometry. So same measure.
Does it mean like same throughout?
Same?
Like same throughout? So like everything's the same?
Everything is same. So
Does it mean
isometry,
the before and the after, the same thing?
isometry is maintained. Here
So
isometry
like
is,
the sides are the same?
yep. Here isometry is not maintained, right? In dilations. Does it make sense there? Any questions on that? I really want to go over a little bit more on this. Isometry is congruence, you can say. Okay. You can call it as congruence. I want to go over a few more on that since I brought it up. Give me a minute. Okay.
Were we supposed to send the answer on the
Not really,
Sure.
not now. Hold on.
Okay.
Yeah. The answer you need to send for the problem.
Okay.
Okay, send it to me. I really want you to guys to know. Let me see.
Wait, Miss Priya, what was the question again?
The question is, I asked you, right? It's on the board. What is the transformation rule, translation rule for the figure shown?
A dash is the original, right?
A dash is the transformed.
Oh, okay, sorry, I mixed it
No
up.
problem at all. I really want to go over. This is not the one I want to go over. Hold on. I really want to go to grade 7, okay? Because that time when I explained, some of you didn't understand certain things, but I want to bring it back now. Let me bring it back. It's quite important to understand this. I think if I bring it back now, it will be better. I'm going to bring it back. Let's go over that quickly. I just wanted to explain some of the important. Isometry. Then is it a part of geometry? Hold on, guys. I really want that. Let me quickly check. Ah, yes. Okay. So rigid transformations are isometric. You all got it, right? Rigid transformations are isometric. Dilations are non-isometric because they do not preserve congruence. Does it make sense? Does that make sense?
Yeah.
Now, another thing that I wanted to bring up. Okay, you're going to send me the answer for that. In the meantime, I'm going to give you more. Let me see.
Wait, the answer for the translation image.
The rule, I'll go ahead and give you, ma. I'll check the answers too. I got several answers I was not checking. I was looking at this isometry and stuff. Okay. Nice, Dia. Okay, I wanted to bring Dia's input here. Another way of writing the rule, guys, one is, see, the rule for that one was x plus 2, y minus 1. You all got it right. Otherwise, you can write it out as t, a capital P, in bracket, you can say 2 comma minus 1. Any questions? You can call it as t 2 comma minus 1. Can I move on? Okay, now let me go ahead and ask you this. I was looking at something else. Let's see. Okay, so when you're given a figure, when you're given a point, you should be able to do it. I told you rigid motion. Okay, now you know what is composition of transformations? Composition of transformations. Let's go over it. Composition of transformations. Here you will have two or more rigid motions combined together. Two or more rigid motions combined together. That is a rigid, composition of transformation. Aditi, correct me. Okay, I thought every one of you got it. So now, composition of transformation means there will be two things together. Okay, meaning you can perform a translation reflection. You can perform two rigid motions when it's done, or you can perform two translations as well. Okay, now let's see this one. I want to perform a composition. Okay, I want to perform a composition. The endpoints are given, meaning, so RS is given, the endpoints, meaning the starting is given. Let me give you that. Okay, what is the composition that's being performed on this endpoints? This is the composition that's performed. So what will be the image endpoints? I've given you the pre-image endpoints, I've given you the composition of transformation it's going to undergo. Can I get the image endpoints after you perform this composition of transformation on this point RS? I want R double dash S double dash. R double dash S double dash is what I want. Can I get that? Send it to me, guys. It should be not hard. Did you get it, guys? Translation is easy, so I'm going to whatsoever move on to reflections.
Wait, Auntie, can you see the definition of this one again so I can write it down, please?
Composition of transformation is a combination of two or more rigid motions performed. Composition of transformation is a combination of two or more rigid motion transformation performed on a point or any figure.
Okay, thank you.
Now, oh, sorry, Prisha, I didn't see that message from you. Diya correct, Manav correct, Akash, that seems incorrect, ma. Vekama for Keyura correct, Navneet correct, Aditi, that seems incorrect. Intermediate points, I have to check, ma. Be careful, guys, meaning you're just going to carry out the rule on these, okay? So, this R is minus 8, 5. Shrikar, what are you doing, Shrikar? I really want to answer.
I'm typing it out.
Okay. So when you perform plus 5 minus 2, right? First transformation is plus 5 minus 2 on both. So it becomes this, right? R dash S dash becomes minus 1, 6. You need to be just careful. That's all. Here it's going to be minus 4 minus 2. So it's going to be minus 7, 1. And then the last one minus 4 minus 2, right? Minus 5 and 4. This is your final answer. Can I move on? Okay. Akshita, I'm thinking you've gotten it. Navneet, I'm thinking you already got it. Did you get it?
Yeah.
Okay. I really want to move to reflection. Okay. Let's see this one. I'm going to consider this figure. Okay. I will try to deal with most of it today itself. Let me see. Okay. I'm going to consider this figure. Now, if I reflect it across the x-axis, if I reflect this across the x-axis, I will do it, I feel honestly. I'll show you what happens. If I reflect this across the x-axis, if I reflect this 2 points down, right? So this point was 5, 2. 5, 2 became 5, minus 2. What is the observation you think if you reflect something on the x-axis, right? What changes?
The what?
The Y.
Y coordinate changes. That's what I want you to understand. Suppose if this point was x, y, reflection on x-axis changes what? Reflection on
The
x-axis.
Y coordinate.
Y coordinate. So, okay, then think about, what ma? So, basically it becomes x, basically this point becomes x, minus y. Any questions on that? Manya, are you with me?
Yeah.
Reflection on y-axis, what happens? X, y becomes, when you reflect it on the y-axis, let me reflect and see. 1, 2, 3, 4, 5. So this goes here. So what becomes of the point A dash? 2, minus 5. That is a reflection on the y-axis, right? So what happens there?
Negative Y, comma x.
Negative x, right? Reflection on the y-axis means negative x, right?
But because like both of the things switch,
Both
5 and 2.
Wouldn't the coordinate for A dash be -5 too?
negative 5. Yes, no, correct me. I made a miss. -5, comma 2.
Oh, never mind. Yeah.
You see that, right? The x negates, y remains the same. That's what I have done it here. Can we go to the next one? Can we go to the next one? Now you understood the reflection on the x-axis, reflection on the y-axis. You know what? I'll give you another image. Here, I'm going to reflect it on the, okay, let me go ahead instead of talking. Let me go ahead and give you this figure and ask you. Did you understand this properly? The first one, can I go ahead and erase reflection on the x-axis and y-axis? Points change how you all know, right? Can I go ahead and erase this on the board? Okay, now
Yeah.
let's try this one. How about this? What is this line? What is the equation of this line?
Y equals x.
Good. Reflection on line y equal to x is the next topic. What happens? Let me try. If I do that, this 1, 2, 3, 4, 5. This is 2, 3, 4, 5. 5 up and 5 down. So what happens? What will be the points? Point E dash. When I reflect it on the line, what will be E dash? Any thoughts?
I think you take the point and apply the formula. If it's like over the x-axis, it would be x negative y.
I don't want you to apply the formula. That's not the intent here, right? I really want you to reflect it and see. You know what I mean? You know what I mean? Okay, let me tell you what I mean. Okay. Let's consider, I don't want to consider E, I feel, because both are one. Okay, E first, let me consider. 1, 2, 3, 4, 5. So now 1, 2, 3, 4, 5. Somewhere here it will come, right? Similarly, 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. Did you see what happened? Meaning I converted the distance from that point to the line to a vertical line. So what happened, guys? X comma y became what?
-x and -y.
Y comma x.
Did it become -x and -y, ma? Why do you say that? Yeah, Manav, but how do you, meaning Dia, what was your thought, ma? See, it doesn't matter if you
Oh,
make
is
mistakes.
it?
Understand? Yeah, go ahead.
Oh, it's y, x.
Yeah, because see, one was positive, the x was positive. X was, see here, the point was what actually? -3, 2. Okay, but then this carried out to this one. Okay, and then this distance, right? The vertical distance became the horizontal distance to the image. So they both switched basically y comma minus x. That means, is it 2 comma -3 correct? Did we get did we get it? No, wait. We got it as we switched to 2 comma it's just switching, right? So y comma x, so 2 comma -3, correct? 2 comma -3. Any questions? So reflection on the line y equal to x, which is your points. Can I go ahead and give you one more? Okay, now before that, right, can I have b dash? What is b dash? After the reflection, what is b dash? It's easy, guys, now. I gave it out to you. I should not have.
So Miss Priya, switch axis.
If we can quickly do the rotation, maybe next week I'll cover, I feel. Okay, at least reflection I'll finish. Go ahead.
Wait, Miss Priya.
Come on.
Which axis do you reflect B dash on?
I am sorry. That's a y equal to x line, right? Meaning, I didn't get your question, Shrikar. We are reflecting on this line, right, Shrikar? So basically, this
Okay.
distance I will replicate to a vertical line. Am I making sense?
Yeah, I get it. I get it.
This horizontal distance I'll replicate into a this vertical distance on the pre-image will be converted to a horizontal line. Does it make sense? So first of all, it's a minus 6 comma. You know what? I would not take the pain of that. Minus 6 comma 8 will become what?
8 comma minus 6.
Yeah, 8 comma minus 6. It just switches, guys, if it is y equal to x line. Manya, are we clear?
Yeah.
What is this line? I will leave you in another 3 minutes, okay? What is?
Y equals negative x.
Okay. There, we understood x comma y was switching to y comma x on the line y equal to x, remember? Good. Now, this became this. Now, we are referring to the line y equal to minus x. What happens here? Let's try. Let's not take the point on the line because it's going to be the same. Let's take which point? Come up with
B.
something. B. Okay, let's.
B.
Yeah, you can as well. See, it's an interactive class, right? 1, 2, 3, 4. See, the problem is it's 4, 4. Okay, that's okay. 1, 2, 3, 4. So what happens now? I'll have to reflect it on this line, right? So 1, 2, 3, 4. What did I do? No. Hold on. What did I do? So here, what should I do? This horizontal distance should be converted to vertical, right? So 1, 2, 3, 4, and then this horizontal distance is converted here. So B dash becomes here. Did you all understand, guys? What are we doing? Kayura, did you get it?
Yeah.
So now what happens with if it is reflected on the line y equal to minus x, right? What happens? You can translate one by one and see if you want to. What happens if you translate x comma y across the line y equal to minus x? Let's note it down for one of the points. Okay, I'll note it down for you. You can let me know. B was what? Minus 7 comma 3. B dash became what? Let me note it down. B dash became. Oh, you're going to reflect it on that line. Oh, is it going to come here? This is where you're going to, okay. B, yeah, go ahead. You have to go. Okay, go ahead. Yeah, so now B dash is what point? Minus 3 comma 7. So what happened here? Did you see what happened? Any thoughts?
Negative y, negative x.
Exactly. They switched their positions. It became 3 comma minus 7. After that, they were negated. They switched their position and after that we negated them. So x comma y, first we switched them, same as above, but then we had to negate them. Did you guys get it? Well, simply don't by heart this rule. First understand how these rules came. So we have covered only translation reflection, right? So I'll give you homework on translation reflection, but translation rule can be written like this, I have told you, right? Meaning translation rule can be given like this, I have told you. Reflection also has different ways of denoting, okay? So we will do it next week, okay? We'll do the symbols next week and continue with dilations next week. Rotations I did not cover. We'll do the symbols, rotations, and composition also there are symbols to be followed. For now, I have just given you an intro on translation, reflection. Homework will be only on this basics, okay? But composition transformations, I might give you with both translation and reflection. You'll have to do that, okay? Any questions, stay. If you don't have any questions, we can leave.
Thank you. Bye.
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 Auntie, I actually wanted to ask you a question. So in class, when you were going over it, I didn't get what you meant by converse of corresponding angle postulate and like I don't fully understand the transitive property of equality.
Okay. If in this case, angle 1 and angle 2 are congruent, then L is parallel to M. Is there a difference between this? And if L is parallel to M, angle 1 is congruent to angle 2. Is there a difference between the two?
No.
There is. This is A part, this is B part. Here B is comes first, A comes next. Did you see this?
Oh,
So
okay.
this one is corresponding angle postulate. This one is converse. You switch both. You got
So
it?
corresponding angles is if two angles are
Equal.
then the lines are equal.
The then part, the parallel is the later, the conclusion. This is the hypothesis conclusion. If hypothesis is L is parallel to M, then it becomes a converse.
Oh, okay. That makes sense.
Okay, that makes sense. And what else you did not understand?
Like the difference between transitive and substitution, like I kind of get it, but I'm
Angle
still
1 is congruent to 2. Angle 2 is congruent to 3. You see this to this to this. You get it?
yeah.
This is transition. Whereas when you say angle 1 is congruent to 2, angle 1 again is congruent to 3. The same angle 1 is being discussed. Do you see there is a straight? Here it's substitute.
Yeah.
You got it?
So you're basically substituting the angle 1 for both of them?
Yeah. We are substituting, yeah. Correct.
Okay, thank you.
No problem.
Oh, and also the PDF that you were showing in class, can you please post that to Google
I posted it
Classroom?
already.
Oh, okay. Thank you so much.
Bye-bye.
Okay, bye.